One of the skills that I want you to leave this course with is knowing how to produce reproducible research. In this video, I'm going to talk about what that means, and then we're going to look at two tools, Git and GitHub, to help us assure that we can reproduce our research. There are additional benefits to using Git and GitHub, primarily collaboration, but for now, I'm going to focus on reproducible research, and then later on, we can learn how to use these tools for collaboration. What is reproducible research? A manuscript is a product of research. It is not the research itself. Reproducible research means that you or anyone can use the same data and follow through the same analysis to arrive at the same results as those that are disseminated in the manuscript. Reproducible research does not mean that the analysis or conclusions are correct. You could do some pretty lousy research and still have it be reproducible research. So what we're focusing on right now is not how to do good research, it's how to reproduce research. A survey of 1,576 researchers, as reported in Nature, highlights a major problem. Over 70% of those researchers have tried to reproduce another researcher's results and failed. Over 50% of those researchers admitted that when they tried to reproduce their own research results, they failed. You are going to acquire some strong tools for reproducible research when you learn about R and R Markdown, and now we're going to add to this Git and GitHub. I want to make sure you're clear of the difference between reproducible research and replicable research. These two terms are often confused, so let's look at each of them. Reproducible research means that you can produce your data and reproduce your research results. That's what we're going to be focusing on. Replicable research means that when research studies are repeated with different samples, similar results are obtained, thus supporting a common theoretical perspective. So replicable research really is about moving the field forward because different researchers obtain the same kind of results when they're studying the same phenomena, so you can come up with general principles for your discipline. The so-called reproducibility crisis is due to researchers who are unable to provide their data or replicate their results. So that survey that was done in Nature that I referenced, that was about the so-called reproducibility crisis. But you'll also hear people talk about the replication crisis. That's due to getting different results across studies of similar constructs so that general theoretical principles are difficult to support. So one of these has to do really with the research process, and the other has to do with building knowledge in the discipline. We're looking at the former of these right now. I'm not going to be able to help you create replicable research in this course because we're focusing on learning R for doing research. What I want you to be able to do, however, is to be able to reproduce all the steps of your research along the way, and that's what this is about. To help us do this, we're going to use a tool called Git. Git is a version control system for tracking project changes. Now you're used to having version control because if you've ever used a cloud-based service like Dropbox or Box or OneDrive or Google Drive, you know that you can put multiple versions of your document into the cloud, and previous versions are not deleted but retained so that if you need to, you can go back to older versions. This is in essence a sort of version control system. However, it's not very efficient for tracking specific project changes, and that's where Git comes in. Git was created by Linus Torvalds in 2005. If you've ever heard of the operating system Linux, Linus Torvalds created Linux, and the name Linux comes from his first name, Linus. It's been maintained by Junio Hamano since 2005. It is free and open source, like all of the tools that we're using in this class, and it is a key element in reproducible research. If you're wondering what Git means, it means unpleasant person in British English slang. Linus Torvalds himself is the one who came up with the name. He said that Linus was already used because of Linux, and he considers himself to be quite unpleasant at times, so he thought that Git was another way that he could name this after himself. Go figure. Here's the Git process. We work in a Scratchpad. In our Scratchpad, that's going to be our studio when we're working on our notebooks. We get to a point then where we want to save what we've done. Now we can simply click the Save button and save it on our computer and continue working. That's still working in the Scratchpad. But suppose now we've decided that we've done significant work and we want to save this as an official version of what we've done so far. We're happy with what we got. We might be going back and forth and changing things, testing our scripts, making sure that they work correct, fixing errors when they don't. And when we're finally happy with what we have, that would be a good time to make a commit. When we make the commit, you can think of moving this from the Scratchpad to the official version of it. So here I've got save 1 and decided, hey, that's a good commit. Then save 2, that's another good commit. Then save 3, but I'm still working on some things, so I'm not going to commit it yet. But now I do some more work and save what I have and now do a third commit. So committing is basically stating that I want to save this as a quote-unquote official version. Now, if you save it as an official version, as you'll see, we can still take things back if we need to. Why use Git? Hadley Wickham, who you've been introduced to as the chief scientist for our studio, said the following: using a Git commit is like using anchors and other protection when climbing. If you're crossing a dangerous rock face, you want to make sure you've used protection to catch you if you fall. Commits play a similar role. If you make a mistake, you can't fall past the previous commit. Coding without commits is like free climbing. You can travel much faster in the short term, but in the long term, the chances of catastrophic failure are high. Commits are also helpful to others because they show your journey, not just the destination. So when you are done with your research, if you've used the Git process, any researcher can follow the path of what you've done. A free online system that we're going to use to be able to use Git with our R projects is GitHub. So here's a little bit of information and background about GitHub. GitHub is a web-based repository for Git-tracked projects. It's for the storage of projects, including commits, in the cloud. It also provides many tools for collaboration. So when you think of GitHub, you can think of those web-based systems I referred to earlier, like Dropbox, Box, Microsoft OneDrive, Google Drive. Those are all web-based repositories. The difference is that GitHub is a cloud-based storage like those others, but specifically for Git-tracked projects so that you can see specific changes from commit to commit to commit. It was created by Chris Wansworth, PJ Hyatt, and Tom Preston Werner and Scott Chaikin in 2008. So let's fast forward just over 12 years later and see what has happened. Well, 5 years after they created GitHub, they had 10 million repositories. A repository is, in essence, a project that someone is using Git commits as part of that project. So you can think of this as 10 million projects were stored on GitHub as of 2013. Then in 2018, 10 years after they started GitHub, they were able to retire. They sold this to Microsoft for $7.5 billion. Up until recently, GitHub provided free accounts for anyone who kept their project open to the public, and then you would pay for an account if you wanted to keep it private. But guess what? Great news. During this past semester, as if in preparation for my course, they made it so that you can get a free account even if you're going to have private projects. So whether you have private or public projects, you can now have a free account. So how do they make their money? Well, they offer paid accounts as well that have more features, but for our purposes, the free accounts are going to work just fine. They offer free education bundles to schools that have additional features, and keep this in mind, they have free upgrades that they offer to students. They have what is called the GitHub Student Developer Pack, and I would encourage you to go ahead and sign up. It's going to require showing your ID and verifying that you're actually a student. But you not only get additional features in GitHub when you do that, but you get access to a whole host of additional developer tools that I own and have to pay for that you would not have to. Why use GitHub? GitHub actually provides an automatic website for your project. We're not going to look at that in this learning cycle, but I will show you this in a future learning cycle. It provides source code for others to be able to reproduce what you're doing, thus reproducible research. Packages in your project can be installed by others. So if you develop a package, you can actually publish it via your GitHub repository instead of going through the CRAN, which is the official repository. I have done that for some classes in the past. I've created a package, put it on GitHub, and then students in my class who were using R were able to install this package and have additional tools for while they were in my course. Anyone, including you, can track the history of a project. You can track the history of a file. You can track who made the commits if you're involved in a collaboration. And comments can be made on commits so that you can see at a glance what that commit changed in the project, what additional work was done that led to that commit. GitHub also provides many collaboration tools. Here are some best practices, again from Hadley Wickham, when you make commits. Each commit should be minimal. That is, a commit should contain changes related to a single problem. So I tend to make commits after I create an R notebook, or if that R notebook is a long notebook or a major project that involves multiple functions that I'm writing, I might make a commit after I have each function working. What I don't do is make a commit when I've only changed a line of two or code. That is, I see the commits as going with the completion of one aspect of a single problem. For a new problem, then I do a separate commit. Each commit should be complete. It should solve the problem. And by problem here, we mean that we've created the code that we need in order to carry out a certain task. If the problem is actually a bug in the code, the commit should include proof that we have solved the problem. Commit messages should be concise. You should see at a glance what the commit was about, and there should be enough detail to understand what was done. Commit messages should describe why, not what. Stating what you changed is redundant. So instead, provide a high-level summary of why the change was made. In the next video, I'm going to show you how to use Git with GitHub.